In this video, we're going to talk about how to find the sum of squares. And the sum of squares is the sum of the squared deviation scores. And it's important because it allows you to find variance. And again, once you find variance, then it's an easy step to find standard deviation. Okay, so the equation for sum of squares is SS equals sum of x squared minus sum of x squared divided by n. Take note that this sum of x squared is different than this sum of x squared. Okay, so let's look over here, and we have our raw scores as denoted by x right here. Okay, so we have somebody who scored a 2, a 1, a 10, a 3, and a 7. Okay, so the first thing we need to do, first step, is to square each one of the raw scores. So 2 becomes 4, 1 is 1, 10 becomes 100, 3 is 9, and 7 is 49. So sum of x, or when I add up 2 and 1 and 10 and 3 and 7, I get 23. Same thing for my sum of x squared. I sum up or add all of my x squareds. So I add up 4 and 1 and 109 and 49, and I get 163. Okay, so let's use sum of x and sum of x squared in this formula up here. Okay, so the first one is sum of x squared. So we know our sum of x squared is 163 minus sum of x, which was 23, squared, divided by n, and our n is our sample size. We have 1, 2, 3, 4, 5. 5 people in our study. Okay, so we have 163 minus 23 squared divided by 5. 23 squared is 692, so we'll go 163 minus 692 divided by 5, or 163 divided by 138.4. So our sum of squares is 24.6. Okay, this next problem is quite similar. We have our raw scores of 1, 0, 6, and 1. We square each one of those raw numbers, and we get 1, 0, 36, and 1. Once we sum up all the x's, we add up 1 and 0 and 6 and 1. We get sum of x of 8 and sum of x squared of, so add up 1 and 0, 36, and 1. So we get 38. We're going to use these numbers in this formula. Sum of x squared is 38 minus 8 squared divided by, we only have 4 people in this study. So we have 38 minus 64 divided by 4, or 38 minus 16. So our sum of squares for this formula, or this problem, is 22.